Hi guys, this is Mrs. Gregerson again. We're just doing the second page of this. Now the first one, number 3, is both from lesson 9.5. We ended up doing that on Tuesday, which was, or excuse me, Wednesday or Thursday on block day, whatever day that you had. And this process is not difficult if you remember the rules. And the first one is finding the area of a triangle. When you find the area of the triangle, it is so easy. And the cool thing is it doesn't have to be a right triangle, but we know it's going to work. If you see SAS, side, angle, side, you may use the following formula to find the area of that triangle. You can go area equals 1/2 BC sine A. Now, here's the part. A is always your angle, and B and C does not matter which, so you can call this one C, you can call this one B, vice versa. They just plug in. They're the ones that surround or include the angle, and all you have to do to solve for the area of this triangle is to make sure you plug it in. So I go 1/2 of B, which is 16 centimeters, times C, which is 9 centimeters, times the sine of 37 degrees. And then you just punch it into your calculator, and I'm going to give you some shortcuts on how to do that. I'm just going to go 0.5 times 1/2. So that makes that 1/2, excuse me, not times 1/2, so it's 0.5 times, and then just go straight ones in here, 16 times 9 times, look at that, sine 37, parenthesis. Hit enter. And if you do that, you should end up getting, and let's go to the nearest tenth again because we're working with length, and even though it's in 2 dimensions here, the area is going to be 43.3 square centimeters. Now really, what this C sine A really is, that's your height of the triangle, but we're not going to worry about the height of your triangle in this case. We're just going to work with what we have. So hopefully that helps you on the first one. But again, memorize that formula. That will help a lot. And then the next one is I'm looking for the area of a regular polygon. And remember, the area for a regular polygon was 1/2 Apothem times perimeter. But our rules with this is you always draw your central angle triangle. I'm not going to be able to draw you a really good octagon. I could do a decent one, but it's not helpful. And remember, there's 8 of these central angle triangles that you're working with. But I'm just going to draw this one out as a side length of 10 centimeters. So that's your sides. If that's my side, couldn't I just go automatically get my perimeter? Because we have 8 sides times 10, and that's 80 centimeters. So at least I know perimeter right away. But I'm looking for my apothem. And remember, our apothem would bisect this side. So if that's the case, when I'm working with it, we should automatically know that this is 5. So that's helpful. But in order to find the apothem, I have to know my central angle. And remember, the central angle is found by going 360 divided by the number of sides. In this case, that's 8, and I get 45 degrees. But what does the apothem always do to that big central angle? It bisects it. So this angle right here really is 22.5 degrees. Now I know I'm using decimal, and I hate decimals. Not hate decimals, I don't like using them a lot of times. But in this case it makes sense because I know I'm going to have to use my calculator to work with it anyway. So now I'm going to look for my apothem, and so I just ignore this part and I realize, oh look, a right triangle. If this is my angle, this is my opposite side, that's my adjacent side, so I'm going to use tangent to solve for the apothem. So I go tangent of 22.5 equals opposite over adjacent. Now this is when you once again use the fact I can go ahead and switch my extremes, and I get my apothem is equal to 5 divided by the tangent of 22.5. Now a whole bunch of you just quickly grabbed your calculator and you started doing the work. Here's my rule. Stop doing that. Don't use your calculator till the very end because you're going to round at the wrong time. So instead, let's punch our stuff into our formula. Remember, our area formula for apothem, of a regular polygon, is 1/2 apothem times perimeter. Okay? So if I do that, I'm going to plug everything directly into it. So I get my 1/2. My apothem is 5 divided by the tangent of 22.5 times the perimeter of 80. Now I'm going to write that as 80 over 1. And the reason why I'm going to do that is I can multiply my numerators together and I can multiply my denominators together. So I end up getting 400 over 2 times the tangent of 22.5. So I go over here and I go 400 divided by 2 times the tangent of 22.5. Put another parenthesis there. And you should get 82.8 square centimeters. Now, I want you to really think through that process. We still have to know our area formulas. We still need to know our trig. We still need to make sure that we have it all worked out. And I just realized I think I punched something into my calculator wrong. Let me see if I can get this to work a little bit better. I just punched it in wrong, so let me clear that for you so you can see how to do this again. It's going to be 400 divided by, and we're going to put a parenthesis here, 2 times the tangent of 22.5, parenthesis. Yeah, now it's going to work out for me. So sorry, guys. I'm looking at this and I said, this doesn't make sense for size length. And I double checked it while I was talking to you, and that's actually going to be 482.8 square centimeters. So please, please forgive me on that formula. In fact, I'll even go for Mrs. Prempos later, rescan those for the area formula so things will work out better. All right, let's do our last one. Clearing this one up. It says, this is going to be one of our angle of elevation, angle of depression problems. Please, please, please draw this carefully. So here's the first one. And an individual was looking from the observatory deck of a Willis Tower down at a bystander, walking about 5 blocks away from the base of the tower, which is about 2,600 feet. So about, a half a mile away. The angle of the depression of the individual in the tower down to the bystander is 15 degrees. How high is the observatory deck on Willis Tower? By the way, these are guesses for distance. This is not an actual to scale problem. Guys, I didn't go and ask how tall the tower was. I didn't look online. I didn't do any of that. So this is a total guessing type idea, but I just wanted to give you an idea what it looked like. All right, so here we have our tower, okay? Here's Willis Tower. And here's your observatory deck, okay? Remember you have that cool glass thing? So you're looking here, and you're looking down at a bystander over here. Okay, and you're going to be looking like a gnat, an ant by this point because you're so high up. But it's using the angle of depression. And remember, which direction do you always look first? You always look out first. Then you look to your line of sight. So the angle of depression is out, then down. So this is 15 degrees. Now, I also know that person is 2,600 feet away. And I also know that the tower, if they built it right, is perpendicular to the ground. So then I'm going to end up going up to figure out how high the observatory deck is, and I'm just going to call that X. Now notice I don't have a triangle drawn over here with the 15, but I'm going to use the fact that my angle of depression and my angle of elevation are always congruent. And may I emphasize, never, ever, ever, ever use this angle. I don't know how many times people get it wrong, and it drives me crazy. That angle is not a depression or angle one. This is one, if you're actually doing it, you're going to fall out of the observatory deck. It's not going to be healthy at all. But make sure you never ever use this angle. You want to, if you're not sure, always mark the angle of elevation because it's always going to be equal to the depression. But now looking at this for this angle, I have opposite and adjacent. So I'm going to set it up. So I go here, the tangent of 15 degrees, it's going to be opposite over adjacent, so I get X times 2,600. So now I'm going to multiply both sides by 2,600 times the tangent of 15 degrees, which equals X. So let's plug it in on our calculator, and this time I can do this one right, I promise. 2,600 times the tangent of 15, parenthesis. And it's about 696.7 feet. And by the way, if you think about 10 feet per story, give or take, it's approximately, you say that would be like 67 feet. And I've never been on the observatory since probably, that was 17, 18 years ago. And so I don't even remember how high it is, but hopefully that will give you a hint how to set up these types of problems, because I know you're going to have to draw one like this on your test. Hopefully this will help you guys, and sorry about the calculator error earlier, but hopefully it'll work out good. Thanks.